All right, and here we have come to the final chapter of Study Guide Review for the Semester 1 Chemistry Final. Okay, so I believe we left off here saying that we had dispersion forces, hydrogen bonding, dispersion forces, hydrogen bonding, dipole, and dispersion forces. Okay, so now we're moving on to the unit 3. So 30, what are the two major differences between physical and chemical changes? So I'm going to start this up here. We have physical and chemical. Okay, so what would be an example of a physical change? Well, maybe like melting water, H2O solid to H2O liquid. That would be a physical change because, as you can see, the structure of the formulas is not rearranged in any way, shape, or form. Hydrogen is not broken apart from oxygen, so there's no real change, okay? Chemical would be like something like we're used to, H2 plus O2 goes to H2O, okay? So we can see hydrogen started out separate, oxygen started out separate, and we formed a new substance, okay? So that's the key here. In a chemical change, you have the formation of a new substance. Whereas in terms of physical changes, you're talking about just a change in form, in phase or content only. You're not actually changing the chemical makeup of the substance, okay? So examples of physical changes might be freezing something, melting, boiling something, okay? All of these change the phase that it's in, but they don't change the actual chemical makeup. That's your litmus test. If something changes in phase, but not the actual, it doesn't actually form something new, then it's not physical. It might also be shredding paper, okay? Breaking a rock, okay? Those are all physical changes. Whereas a chemical change forms a new substance, right? Some examples might be a battery, okay? Batteries, you have nickel on one side, cadmium on the other, and they react with each other, and there's electricity. It might be metabolism, your body converting the food that you eat into energy and into the other substances that make you up. Combustion, anytime you're burning something, that's going to be a chemical reaction. What's another chemical reaction you'd be commonly familiar with? Cooking. Generally, cooking food in the sense that it changes colors or does something like that, you get changes in smell. That is typically a chemical reaction. But remember, or formation of a gas. It has to be one of the examples or the 4 signs that a chemical reaction has occurred, which leads us to 31. 4 signs that a chemical reaction has occurred. There could be a temperature change. Okay, and this is from the chemical reaction itself. So heating something up in the microwave or on a boiler plate or a hot plate does not work. Okay, this has to be a temperature change when you combine 2 chemicals and then they either get warmer or colder for no other obvious reason. Okay, color change or formation of a gas or formation of a solid. Any of these things will qualify something as a chemical reaction, okay? 32, define the law of conservation of matter. Okay, so it's pretty straightforward. in a chemical reaction, matter is conserved. What do I mean by conserved? I mean that it can't be created or destroyed. Cannot be created or destroyed. Okay? So we saw this when we performed various different reactions where we bottled the gas inside the reaction, and we saw that before and after the chemical reaction there was no change in mass. But a chemical equation also helps us define that because it shows us what the ratio needs to be, and it demonstrates how one side has to be balanced with the other side. In other words, the reactants must be balanced with the products. Okay? Now I'm going to balance these chemical reactions. Okay? So potassium sulfate reacts with barium chloride to give us potassium chloride and barium sulfate. Well, the first thing I'm going to do is look for an imbalance, and I see two imbalances. I see that potassium is not balanced, and I see that chloride is not balanced. So I notice that putting a 2 here will fix both of those issues. So I put the 2 here. Boom. Now chloride and potassium are balanced. But what about sulfate? So we need to check that out. Well, I see one sulfate here, one sulfate here. So we're good here. And I see one barium here and one barium here. So we're good here too. So balancing this was pretty straightforward. We just need 2 KCl's, right? And so 1 times 2 is 2 potassiums, 2 KCl's right here. Sulfate is SO4, and I have SO4 here too. So 1 sulfur, 4 oxygens, 4 oxygens. 2 potassiums, 2 potassiums, 2 chlorides, 2 chlorides. Okay. These green numbers are the number of molecules. Remember, you can't mess with the recipe. If you mess with the recipe, then instead of baking a cake, you're going to bake some kind of weird other thing, okay? I messed with the ingredients of my pizza last night. Instead of getting pizza dough, I added way too much water, and I ended up with pancakes with cheese and toppings on top of them. It was okay. We ate it, but not the best. Anyways, moving on. Looking at this one, again, I'm going to look for imbalances. And the first imbalance I notice is between chloride. There's two chlorides here, but only 1 chloride here. So we're going to fix that by adding, right? We can't get rid of this chloride, so we have to add over here. That gives me 2 NH4s. So that makes me feel like I need to add a 2 here. So I have 2 NH4s. NH4 is ammonium. But that gives me 2 oxygens and 2 hydrogens. Well, if I look over here, oxygen and hydrogen have a 2 after them, indicating that there's 2, this is called a hydroxide functional group. There's 2 oxygen hydrogens here already. So I can just put a 1 in front of that. And if I did this right, I should also have 1 calcium over here. And I do. And I have 2 chlorides on this side? Yes, I do. So there's my solution. Okay. This one. Here's a good strategy, and it's if you have a whole bunch of something, like more than 6 atoms, you're probably good here with a 1, okay? I'm going to use a 1 here, and if I need to go back and change it later, I will. But generally, when you're balancing equations, you don't need huge numbers of atoms. So let's just try this and see how things work out. So I have 2 vanadiums over here, so I need 2 vanadiums over here. So I'll put a 2 here. That fixes vanadium. Now I can move on to oxygen. So I have 5 oxygens over here, so I need 5 oxygens over here as well. So I put a 5 there, boom, 5 oxygens. And then now I have 5 calcium, so I can put a 5 here. And then we're good. Now for this last problem. Now, I am seeing here that oxygens are imbalanced. So since there's 3 here, I'm going to put 3 here as well. And that gives me 6 hydrogens. So I'm going to put a 3 here to give me 6 hydrogens over here as well. Now hydrogen and oxygens are balanced, but I need to balance iron. So I have 1 molecule here, and I need 2 iron. So I have 2 irons on this side. I need 2 irons on this side. So I put a 2 there, and boom, we're good. All right, I hope this has been helpful for you. Good luck tomorrow. Yeah, get some sleep, get some rest, eat well on the day that you're taking the final. Email me if you have any questions. Otherwise, I'll see you guys tomorrow. Bye-bye.